Assalamualaikum and greetings to our lecturer, Madam Niza, and to fellow viewers. Okay, my name is Muhammad HAZIM bin MAZLAN and my partner is Muhammad Syafiq bin Yaakob. We are going to present our Lab 5 shift register. Okay, moving on to this lab. So there are basically 6 classification of data movement in shift register. We are going to look into SIPO, which is a serial in and parallel out, and the PIPO, with a parallel in and parallel out. So this is the diagram for SIPO shift register. As we can see, the data input is serially loaded 1 bit at a time, with the stored data being available at the output in parallel form. As we can see here, while the parallel for the PIPO shift register, the parallel data is loaded simultaneously into the register and transferred together to their respective output by the same clock pulse. Both are using same clock pulse. Okay, moving on to the procedure, which is first phase part 1, the SIPO shift register. So basically what we have to do is connect the D flip-flop to be used as a 4-bit SIPO shift register as shown as this figure, and we use 3 switches. One of them is to be used as data input, and the second is for the clear pin, and the third is push button to use as a pulser. So the data that I've given to us is 1011, which is to be set using the switch 1, and that switch 2 is used as a clear button, while the push button is used as the pulser button to allow data to be shifted into the shift register. Okay, going into the multisim, this is our circuit that we have done. So first, I'm going to run it, and then first what we have to do is we have to set both of them to be 1, both switches, and according to the data that we are given, which is 1011, the first data will be 1, so we have to switch on the switch on it, and then press the button. As we can see, the first LED will light up while the rest is 000. The value will be 1000. For the next is 0 value, so we switch off and we press the button. The second pulse will be 0100, and the third pulse, which is 1, so, and we press the button. The third pulse will be 1010, and the fourth will still be 1 value, so we press the button. The fourth will be 1101. Okay, the fifth, which is still 1 value, so we press the button. The 5th clock pulse will be 1110, and the 6th is 0 value, so we switch off and we press the button. So the 6th value will be 0111. The 7 will be 1, so we switch on back the switch, and then we press, will be 1011, and the 8th pulse will be 1101. Okay, so according to the multisim, the value is according to the data value that we have put. This is our table for the input data. Okay, that's it for part 1.
Hi, Assalamualaikum. I'm Muhammad Syafiq. Will explain part 2, PIPO shift register. As we know, PIPO stand for parallel in parallel output. So in part 2, we need to connect the D flip-flop to be used as a PIPO 4-bit shift register, and connect the 8-bit data switch to the D flip-flop input, connect the output of the D flip-flop to the LED display. So that was the output, and observe the LED display and fill in the table tree with on or off after the 4 clock pulse, which is we use 000 until 1111. Here is part 2 in Multisim simulation. What component we use in this part 2? First, we use VCC with 5V. We use 4 switch SPDT single pole double throw 4, and 4 IC7474N, 4 LED switch, and 1 digital source V1 1 kHz and 5V. Here is show is this parallel input and parallel output. for parallel in data, number of clock pulse needs are equal to 1, and for the parallel out data, number of clock pulse needs are equal to 0. So I will show the simulation. So I run first. In table, ask us to using data 0, 0, 1. So S4 is 1. So LED 4 will light up, and the others is turn off. So here we can see whenever switch is 0, turn off, LED also will turn off. And whenever the LED turn on, the switch turn on, LED will light up. So 0, 0, 0, 1, 0, 0, 0, 1. So LED 4 will turn on, and it will continue like normal when you turn on the others LED. Here S3, S2, S1. So whenever we turn on the switch, the LED will light up. Here is the truth table for part 2. We use all the data given to put in the Multisim simulation, and we just put whenever the LED is turned on, we put 1, and whenever the LED turned off, we put 0. So we using 4 LED 1 until LED 4. So this is the result. So in discussion, in this laboratory experiment, we know that the shift registers are made up of a series of flip-flops and are used in applications that include data storage and transfer or movement in a digital device. A register has no predetermined state sequence and is typically used to store and shift data 1 second and 0 second received from an external sources. All the registers are driven by a common clock signal, making them as synchronous devices. Basically, shift registers operate in one of 4 different modes, which are SIPO, SISO, PISO, PIPO. Since this experiment touched only SIPO and PIPO, we evaluated that for serial input to parallel out SIPO, the register is loaded with serial data, 1 bit at a time, with the stored data being available at the output in parallel form. For parallel input to parallel output, the parallel data is loaded simultaneously into the register and transferred together to their respective output by the same clock pulse. For part 1, which uses SIPO shift register using the data input 1011 via S11 switch, we press the push button to allow data to be shifted into the shift register. The result were recorded inside the table up until 8 pulse. For part 2, which use the PIPO mode, the experiment results that we have gathered are equivalent to the data input that we set into the switches. Results were recorded inside the table. Conclusion. To conclude, in this laboratory experiment, we are able to explain the operation of the SIPO, PIPO, PISO, and SISO shift register. Furthermore, we are able to construct 4-bit serial input or parallel output SIPO and 4-bit parallel input or parallel output shift register using D flip-flops. Lastly, we have been able to perform the experiment via online multisim software